All right, we are working on greatest common factor, and what is our I can statement? I can statement is loud. I think we should probably let Michelle do this one. As loud as you can, Michelle. What is the I can statement? Michelle says I can find the greatest common factor. First of all, do you know how to find the greatest common factor? Michelle. Good luck as you move on into your new school. Hopefully, you show everybody how to do that really well. Okay. Vocab, greatest common factor is a word you need to know, or we'll skip right through that. There are two ways to calculate greatest common factor. We talked about number one, listing all the factors. Is that a really good way of doing it, you guys? No. If you take the number 100 and you take the number 250 and you list all the factors for 100 and you list all the factors for 250, and then you circle all the ones that are in common and then find the biggest one, is that really fun to do? Yes or no?
No.
You guys look bored. That is not that much fun, is it?
No.
Plus, you could miss some, couldn't you?
Yeah.
So we said, okay, there's really another way of doing it. Way number two. It's not any quicker, but it's way more accurate, and you guys had a lot more confidence in your process here. So we did factor trees. We found prime factorization. We wrote it in exponential form. Yes or no?
Yeah.
And then we found the key to this whole lesson is after we found the prime factorization of each of our numbers, which I'm highlighting in blue right now, we found common prime factors and multiplied them together. So our common prime factors for the numbers we're working with here, which was what were our numbers here, you guys? 100 and 250. We found that they had a 5, a second 5, and a 2 in common. When you multiply those together, we found the GCF being 50. Yes or no? The last thing we worked through was this word problem, and hopefully you added our little sidebar here, because the way I wrote it wasn't super clear. So if you had that written in, we're looking for the greatest amount of teams that Anthony could make, the greatest amount of teams that Huda could make, so that they're evenly competing against one another. We did the same thing we just talked about. A factor tree for 72, a factor tree for 64. That's how many kids they had in their camp if you read the problem. Found the prime factorization, found common prime factors, multiplied them, good to go. I'm worried about the expressions on your face. You should be super pumped about this. Yeah, much better. Okay, we'll do real world in a second. Any questions before I stop the video, Jacob? Questions? Multiplication is always going to be a dot, right?
Yes.
We're no longer using a times or an x sign for multiplication. Okay?